Hello, my name is Hamid Augab. I'm an IT strategist and educator with LearningTree. I'm also an author in the areas of program, project management, business analysis, as well as agile. And you can connect with me through LinkedIn. Today, I would like to talk about the critical path. So we'll talk about what it is, how do we evaluate it, and most importantly, what does it mean for a project manager. So assume we have a project network that looks like this, where we start at a certain point, and then we have tasks layout like this, A, B, C, D, E, F, G, H, and the green marks are basically the durations. As you know, the start and the finish are both milestones, therefore they have a 0 duration. So the critical path is really defined as the longest path through this network. How do we do that? For example, I'm going to go and calculate the length of one path for you. If we start here on the start and we go to task A is going to take us 3 days. Then we'll go this way to D, that's another 4. So we have 7 days total. We go to G, another 3, that's 10 days. So this path here, its duration is 10 days. We're going to go and calculate another one, just to show you how these things work. I can go also from start to C, that's 5 days, to F, that's another 2, and then to H, that's another 4, so I have 7 and 4. This gives me what? 11 days. Therefore, this is the winner right now, and this one is not, because it's less than the 11 days. And as you can see, we have more ways that can take us from start to finish. Another one might be this one. We go from here to B, that's 2 days. E, that's another 5, so we're 7 again. And here another 4, so we're talking about what? Another 11 days. So right now we have a conflict. Both of these can be the critical path so far. The problem is, do we have any other paths? And by looking at here, I think we do. So let's take a look at some of the other paths. For example, we can go this way. From here to A, that's 3 days. And then we go straight to here. So 3 and 5 is 8, plus 4, that's 12. So this one is 12 days. Therefore, again, we have a new winner. We're going to eliminate the other 2. Do we have any other ones? Yes, there is one more. Let's go do it. We go again to A, that's 3, and we go to D, that's 7, and we go from there to here. That's what? 7, we're talking about 11, right? So another 11 days, therefore it's not good. So right now, the winner is the 12 days. I'm going to check if there is any other one, and there is not. Therefore, what do? We are going to actually say we have a critical path, and we're going to highlight it with the red tasks. Therefore, it's going to be from here, start, going to A, I think. That's our critical path. Going to E, this way, right? Yes. And then going to H, and then going to the end. That's our critical path, meaning this is the path that controls the duration of our project. The other ones, the ones that end up not on the critical path, for example, tasks D, tasks G, F, and C, and also B, all of this do not control the length of the project or the duration of the project. Does it mean that they're not important? No, they're very, very important. Does it mean we don't have to do them? No, we have to do them to finish the project. It just means the red tasks are the ones that control the length of this project. So let's go now and see what does this mean for a project manager. And to do that, I have here one task. Let's say this is task X. We're going to calculate the earliest start for this task and then the earliest finish for this task by doing what we call the forward pass. And then we're also going to calculate the latest finish as well as the latest start by doing a backward pass. And then each task where these two values are the same, these two values have to be the same, otherwise you made an error. That task is a critical task. Those tasks where there is a difference between this value, that task is going to have the same difference between these two, and that task is not a critical task, and it has what we call a slack, also known as a float, equals that difference right here, or this difference, which should be the same. Let's take a look at an example. I have task A here, and then task B, let's say, and then task C. These tasks are connected to each other with a finish to start relationship. So if I calculate, for example, we go to task B and say, where is the earliest time we can start working on B without pushing task A backward? Can I work on it here? The answer is no. If I do that, I have to push task B backward. Can I work on it here? Yes, that's not going to disturb task A at all, but is that the earliest? And the answer is no. What is the earliest? The earliest is actually right here. So I'm going to erase these two marks here, and I'm going to go in and say this is going to be called the early start for task B. And usually earliest finish equals earliest start plus duration. Therefore, the earliest finish is going to be here. Earliest finish for task B. Now going backward, when is the latest finish where I don't have to disturb task C? Again, is it going to be here? The answer is no, because if I finish that, I have to push C back forward. I don't want to do that. Is it here? Yes, if I finish here, I don't have to disturb C, but is it the latest place? And the answer is no. The latest is actually right here. So again, we're going to erase these marks here and call this guy the latest finish for task B, and then latest start equals latest finish minus duration, which brings it right here. Latest finish for B. What does it mean? See, this task here has these two values equal and these two values equal. It makes this task a critical task. Let's do the same thing for the green task, which is task D now. Task D. I think you can agree with me that the early start is right here. So this is the early start for D. The early finish is right here because it's duration. Earliest finish for task D. Now what is the latest finish? I can finish all the way up here without disturbing task C. So that's latest finish for task D. And then latest start is latest finish minus duration. It's around here. Latest start for task D. And as you can see, there is a difference now between the earliest finish and the latest finish, which is this distance right here. And it's the same distance between this guy and this guy right here. There's a difference. Therefore, we can say task D is actually not a critical task, and it has a slack equals float equals this duration. Again, what does it mean for you if you are a project manager? It means that task B, you cannot move it. You have to basically schedule it exactly this way. If you move it one way or the other, you're going to disturb the duration of your project, the entire project. But task D, you can schedule it just like that, or you can schedule it, like this. I didn't pick up the right. You can schedule it like this, or like this, or like this. And you are not going to disturb the duration of your project at all. You can also, if you want, divide it into two parts. You can have one part of task D here and another part right here, and it's not going to do anything. Or one part here and another part here. Or you can also schedule it like this, completely like this, or like this. There are so many ways that you can start or basically schedule task D without disturbing the duration of your project. That is what the critical path means. I hope you guys enjoyed this lecture. Next time we'll talk about how to do the forward and backward pass. Goodbye.